The main core is the social and economic benefits surrounding and applications. We have a host of applications: space science and exploration, climate and environment, earth observation, satellite navigation, and satellite communication. So we have four broad categories of satellites. This is presently operational: space infrastructure. Communications, we have 18 satellites; navigation, 9 satellites; earth observation, 22 satellites; and space science, 4 satellites. In the communication, basically this satellite will be put in the geosynchronous orbit, so that the satellite is continuously visible to the particular point, let's say over India. And we have a transponder capacity of S band, C band, Q band, and Ka band. And we also have high throughput satellite capacity. And also we are having some transponders hiring from other satellites. And navigation, we have 9 satellites, as I told, and we are having a NAVIC, that is navigation with the Indian constellation. And this is also, the satellites are placed in geo orbit and GSO satellite constellation. And this also will provide 24/7 operating ground segment and space-based augmentation system called Gagan. And Earth observation, we have another 4 broad categories. One is optical observation, microwave observation, meteorological observation, and other categories. And space science, right now we have 4 satellites. One is AstroSat, Chandrayaan 2 orbiter, which is going around the moon, Aditya L1, which is constantly studying the sun, and ExpoSat for a polarimetry satellite. Now, coming to the applications, space technology, almost day to day, our activities, whatever the day to day activities, almost every sectors we have an application from the space technology: agriculture, climate and environment, defense, security and safety, energy, extractive industries, finance and commerce, transport, health, medicine and pharmaceutical, manufacturing, tourism, logistics, telecommunications, science research and education. All these applications, the goal is to give an input and meet the sustainable development goals. And now I will be covering one by one applications. We'll start with the SATCOM application. We have started the SATCOM program from 1980s. Till now, we have an active program. We started with INSAT 1 series of satellites, then INSAT 2 satellites, 3 satellites, and INSAT 4 and GSAT satellites. Right now, we are having 18 operational satellites, and also which includes a high throughput capacity. Now, the trend is we have to move towards 1 terabyte bits per second, high throughput satellites, and higher bands, flexi payloads, and satellites with 100 Gbps. And also there is a trend of putting the communication satellites in the low Earth orbit, so that the latency can be reduced to a greater extent, and it will have more coverage. And coming to the applications, almost we have television services, broadband services, mobile satellite services, strategic services, societal applications, radio broadcasting, VSAT services, very small aperture terminal services. And there are also a lot of emerging applications like Internet of Things, machine-to-machine, 5G, thin data service. Now we'll see one by one the applications. So coming to VSAT cluster management, internet and e-governance. And also we have direct to home broadcast services. Directly, a lot of DTH service providers are there, like Tata Sky, Airtel, Sun Direct, Dish TV, DD Free, Dish. And we have more than 17 million users with more than 900 channels. And the next important application is the telemedicine application. This will be connecting the patients with doctor using a satellite communication. There are this application is almost 200 hospitals have been connected with the remote, where the patients are connected from the remote hospital with the specialist and the specialty hospital through a satellite communication, where direct interaction with patient through video conference is possible. And also it will guide the local doctors on treatments and procedures. And there are many telemedicines in the field of cardiology, radiology, pathology, ophthalmology, oncology are being utilized effectively. And the next one is the tele-education application. This is also a very, very active and vibrant application, wherein we are connecting through a satellite with the remote, again with the remote students, where they don't have a much access to the very city kind of colleges or schools, where we can connect primary and secondary schools, higher education, universities and professionals, and also distance education. This has been implemented across the country, and we are seeing that large student populations are getting benefited from this. And we have expert lecture, interactive classes, and only the one-way communication also is possible through the tele-education application. And the next important thing is real-time train information system. This is one of the very useful thing where we have put a transponder onto the goods and passenger trains, and through satellite like GSAT-6 satellite, we have a communication from the locomotives to the ground station, which is located at Delhi, and finally through CRIS, we are disseminating this data so that we will be getting the position of the locomotive the years to come in 3 to 4 years of timeline. And another important application is satellite aided search and rescue system. This is again is being widely used, and the international program, the COSPOR and SARSAT is having is the main international program where 44 countries are involved, and India is also a member supporting this satellite payload ground station and mission control center. And this is having an application on the ships, aircraft, and IIRS in distress through radio beacons. And India also supports Nepal, Bhutan, Bangladesh, Sri Lanka, Maldives, and Tanzania. And coming to the follow-up search and rescue program, we have this distress alert transmitter, which will be put into which is a low-cost and affordable system where the fishermen can carry, and they can go deep into a sea and see that if any emergency message has to be sent in case of any emergency. And this is a very useful thing, so that it will give an immediate alert message so that the rescue team can rescue the fisherman. And also, like I was telling about the locomotive device where these transponders are fitted into the trains. Similar way, we also have a plan of fitting into the ships. Right now, 1 lakh terminals are planned to fix into the boats and ships, and already NSIL is taken up, and they are going to implement this. Already the work in progress is going on. ISRO will provide the technology and support, and this is also will give all these communications. In addition to that, we will also be giving weather alerts, like if any cyclones are coming, and also it will give potential fishing zone messages so that the fisherman can go and catch the fish where it is required. And also it will also give a broad like international borders and such things. And now coming to the second applications, that is NAVIC applications. We have a navigation with Indian constellation. We started with the IRNSS series of satellites. We had 7 satellites in that series. And now the next generation of navigation satellites have come. Already 1 satellite has been launched. And we will be giving the service in both SPS and RS range, that is satellite positioning service as well as restricted services. And we also in the NVS-1 satellite, we have included L1, L5 and S-band services with the indigenously developed atomic clock. And as you can see in this picture, where the Indian region is the primary service area, and beyond that also we have a NAVIC service area where it is a secondary service area. And we have again a host of applications from NAVIC satellites. One is the mobility, that is vehicle location tracking, real-time tracking of trains, location-based and emergency warning systems services. And industry also is well utilized, like vehicle telematics, precision agriculture, drones, and also infrastructure such as time synchronization, time dissemination, reference stations. And also it will also serve as a science studies like oceanic studies, atmospheric studies, and so on. And some of the glimpses of the NAVIC applications, like you can see vehicle location tracking and also emergency warning, drones, timing synchronization. And some of the more emerging applications like autonomous driving. This will be aiding for an autonomous driving, precision farming, highway tolling, integration with 5G, 6G network, geodetic reference frame, and so on. And now coming to the third important applications, that is remote sensing applications. So as any other program, we have it's enabling a national development program, improving quality of life, and EO system in the center, where we have space segment, ground segment, user segment, and applications, which will have an application domain of sustainable development, governance, and disaster risk reduction. Now, this is the roadmap of the India's Earth observation satellites, which started from 1979 with the Bhaskara 1 and 2 satellites, with the series of satellites post Bhaskara 1 and 2 launch, like IRS satellites, like IRS 1A, 1B, 1C, 1D, and with the OceanSat first series of satellites, ResoSat first generation of satellites, then Cartosat 1 and Cartosat 2 first generation of satellites, then moving on to OceanSat 2 second generation of satellites, ResoSat second generation of satellites. Now we are moving towards OceanSat third generation of satellites and ResoSat third generation of satellites. Now we are moving towards NISR launch also, and a host of satellites are going to come in the future, near future also. And one of the important application is space inputs. The space inputs are used for food security. For example, it will be giving an agriculture decision support system, which will enable the decision makers to take a decision with the remote sensing data. So one of the thing is 25 crops. We are having a production forecasting of 25 crops with the crop acreage. And you can see in this bottom picture, one of the picture is site suitability for mango, where the soil depth and texture, soil moisture, slope, rainfall, temperature, land use, land cover, all these data are effectively utilized for making a decision. And the next important application, as we were doing from the remote sensing technology, we are taking the remote sensing data. We are also concentrating on institutionalization of the program also. Like, for example, green fodder estimation, where Amul Remote Sensing Center has been established with the collaboration of ISRO, and also with other programs like improved crop inventory using AAML, agromet products for advisories, smart sampling techniques. And the main users are Ministry of Agriculture and Farmer Welfare. And the next important application also is bioresources and biodiversity, where you can see on the right side the picture, which shows that the biological richness map of Eastern Himalayas, where 125 vegetation types have been identified, 7,000 species database have been collected, and also over the time phase of satellite data, we'll be able to tell the degradation factor, so that effectively the bioresources and biodiversity applications are utilized. And the next one is the support for managing flood disaster. One is for preparedness and another one is for the response. Before the event occurs, what is our preparedness? And before the event occurs, what is our readiness level? And post the event also, we are having a lot of data to effectively salvage the issues. Like, for example, preparedness, we have flood hazard zone atlas and national flood affected area atlas, like with the 25 years of flood indentation data, where we will be able to provide with the time series of historical data, and special flood early warning system for Godavari and Tapi. And response also, we have on the right side, you can see the 1,500 flood maps, value-added products have been given in the last 5 years, which analyzes 6,000 satellite images. And there are various users for this also, MHA, that is Ministry of Home Affairs, and the National Disaster Management Authority, and State Disaster Management Authority for flood disaster management. And then another one is important thing is the national wide inventory of renewable source energy, that is solar farms, using the IRS list 3 data images and deep learning techniques, wherein we will create a host of database. It is not only a database, and also it will give a site suitability for renewable energy source, so that it will be useful for the users, where they can come up with the suitable site. And another important application is sustainable cities and villages. Using an Amrit program, where we have an high resolution data, these data are used for master plan, like urban planning and city planning are effectively used with the panchromatic camera of images, like Cartosat 2 and 3 applications from Cartosat 2 and 3 satellites. And also we are using it for 34 panchayats development planning for land resource development and water resources development. And another application is this space inputs are used for weather forecasting. We started with INSAT 1 series with 2 bands, visible and thermal infrared range, with 4 images per day. And we moved on to insert second generation of satellites with 4 images per day. And also we moved on to insert third series of satellites with 6 bands, that is visible, SWAR, MWR, and TIR, with 48 images per day. we are producing 30 products at every 15 minutes interval with you can see on the right side where INSAT 3D and 3D are imaging in staggered mode is shown here, where now also we are planning with the INSAT 4th generation of satellites, which is an upcoming series of satellites where a lot of active programs are planned. And another important thing is the Bhuvan platform. It's a one-stop platform where for all the governance applications like 40 state and central ministry departments are using this data. It's a one-stop portal wherein all these applications are used. And another important thing is the Krishi Decision Support System, which is recently inaugurated, launched this year on the National Space Day, where it is effectively used for evidence-based decision-making by government. And another important thing is the support for government flagship programs. As I was telling about the Bhuvan portal, and the Bhuvan portal has got all the remote sensing data, which is used effectively for various programs like government flagship programs such as Rural Employment Guarantee, Rural Roads and Housing, Watershed Development, Monitor Judicial Infrastructure Facilities, Green India, and PM Gati Shakti programs, and so on. And like Bhuvan portal, we have another important portal is Vedas, visualization of Earth observation data and archival system. This is mainly meant for students and researchers there where this remote sensing data can be used as an input for solving their research questions. Mainly it addresses for it acts as like a platform for big data analytics and AI ML tools. And this can be utilized, researchers can well utilize this remote sensing data with this URL vedas.sac.gov.in. And another important application is National Database for Emergency Management. And this is also is being used for all this disaster management effectively for base data, infrastructure data, thematic data, points of interest, and satellite data. And also we have climatic and environmental study using a national information system. Essentially, we are having essential climate variables that is from terrestrial, ocean, and atmosphere, where these data are used as an input for the modeling. And you can see on the pictures where land cover, ocean color, cloud cover, snow cover, ocean currents, and lightning, where this is an effective input for a modeling. And some of the upcoming Earth observation missions, like we have a RISOSAT 3 series of satellites with wide swath imaging with improved spatial resolution and also high resolution stereo images, and RISAT 1 series of constellation of satellites for all weather day and night imaging, and L and S band SAR for again all weather day and night imaging, high resolution constellation of satellites for daily revisit of areas with the areas of interest, and OceanSat 3 series of constellation of satellites. Having launched OceanSat 3, we are having a 3A, 3B satellites, upcoming satellites. And also I was mentioning about the INSAT 4th generation satellites for meteorological observations. Now we are moving on to the last application, that is space science applications. So again, coming to the roadmap, as you can see in the top side, where sounding rockets are used for launching science-based experimental satellites as a piggyback experiments, like starting with sounding rockets, Aryabhatta, SWAS, Indian X-ray astronomy experiments, and solar X-ray spectrometer. And the bottom one is a dedicated space science and planetary exploration missions, which were launched. You all are aware that Chandrayaan-1 was launched in 2008, which detected the water molecules, and then MOM, that is Mars Orbiter mission, which was launched in 2013, where it captured the Mars planet, and Astrosat, where it is for various host of science studies like aeronomy, astronomy studies, and Chandrayaan-2, we had orbiter and lander. Orbiter was basically having an high resolution payloads compared to Chandrayaan-1, and even now it is giving a plethora of science data. Even though the mission life was 1 year, now it is more than 4 years over. Still, it is giving a lot of science data about the moon. And the Chandrayaan-3 is basically an in situ measurements. Even though Chandrayaan-1 and 2 was measuring from a distance, that is a remote sensing measurement, whereas it is a complementary in nature, where we got an in situ measurement. And Aditya L1 satellite is meant for studying the solar related studies, sun related studies. And XPOSat is another important satellite we launched last year, which is a polarimetry satellites. And also we have future space science and planetary exploration missions like Luna sample return mission, Venus mission, Disha atmospheric science mission, Luna polar exploration missions like ISRO JAXA mission, and ExoWorlds. And we also have Mars landing mission and Astrosat follow-on missions. And also we have a active program till the crew landing onto the moon. And some of the science missions also, we have a societal impact and scientific discoveries. One is the long-term investment to humanity, exploring the solar system and expanding knowledge of the universe through space-based observations. Like we also have lost a lot of spin-offs and innovative solutions from the technologies, whatever we have launched through the satellites. Like one of the thing is indigenous capability to make X-ray mirrors out of Astrosat satellite. And another important technologies which we have got from the Chandrayaan 2 and 3, where the altimeters were first time developed, laser-based altimeters, cameras, and radars like in the carband radars for planetary missions, and standalone automation of spacecrafts, like one of the example is Mars orbiter mission. And also it gives education and HR training. It creates a knowledge pool in the country. From the Luna science meets, data analysis workshops, Astrosat and Aditya L1 support cells, we have a lot of research proposals which is available for the university faculties to pursue advanced research. And also it brings inspiration and motivation. It stimulates the curiosity of aspiring younger generations to take up careers in science and technology, and compelling urge to explore and understand the universe we live in. And one of the important differences I brought in here, the knowledge and addressing the open questions, like Luna science before Chandrayaan and Luna science after Chandrayaan. You can see here, we didn't have an understanding. We thought the moon is a bone dry, whereas we discovered the presence of water molecules on the surface, subsurface, and exosphere. And we thought moon is geologically dead, whereas now we discovered moon is dynamic and volcanically active. And we thought moon's regolith completely absorbs imaging solar wind protons, whereas 20% of solar wind protons are reflected back to space as energetic neutral hydrogen atoms. And we thought moon does not have magnetic field, but we now discovered that presence of mini magnetosphere on the moon presence is there. And we thought lunar surface is vulnerable to impacts, and hence human settlements is not possible. Whereas now we are based on the image of potential site where buried lava tube for future human habitability on the moon is also being discussed. And no solar flares during quiet sun period was our understanding. Whereas now detection of large number of microflares during the quiet sun period and insights to coronal heating puzzle also is being analyzed. And moon is heavily cratered. We thought moon is heavily cratered and it's difficult to land on the surface. Whereas now with the sharpest images, which is the best available in the Chandrayaan 2, one of the payload called OHRC, Orbiter High Resolution Camera, where it gives a 25 centimeter spatial resolution, which is the best available globally now at present. And we have seen that we have thoroughly characterized the landing sites with less than 5-meter diameter craters and 1 to 2-meter boulders. And we also did not have any understanding that southern region, high latitude regions have many unknown aspects. Now we have characterized that after the successful landing of Chandrayaan 3 lander, we have characterized the ground vibration signals with high vibration accelerometers, plasma environment, near surface plasma environment, thermal profile, and elemental composition at near to the south pole. And we all know that declaration of National Space Day by Honorable Prime Minister, a tribute to Indian space program. We have marked this National Space Day on 23rd August, landing day of Chandrayaan 3, would be celebrated every year by the entire country. And the Shiv Shakti point, all of you know that we were the first one to land near to the South Pole at high latitude, whereas the fourth country to land onto the moon. We landed at 69.3 degree latitude towards south and 32.3 degree longitude towards east. And this brings sense of pride and enthusiasm among all the people in the country. This is only possible only through these missions like Chandrayaan and MOM. Thank you so much for your attention.